Good afternoon, good morning, good evening, depending on where you are on this fast forward planet, which is well into the fourth year of what doesn't seem like a pandemic anymore, but is. It's still the WHO hasn't dropped the global health emergency tag. We're coming up on the first year anniversary of the tumultuous and immoral invasion of Ukraine by Vladimir Putin. It's a human heated planet with manifestations of that playing out everywhere, from Antarctica, where the sea ice is really low, to right here in Maine, where I live in Wabanaki territory, where the mud season has come way early. Our road almost swallowed our car this morning. And and that's just a minor part of what's going on. And we're building vulnerability in many places. In areas of all kinds of hazards. The earthquakes in Turkey and Syria show manifestly and tragically what can happen when the human surge takes place in ways that don't account for the risks this planet can pose, the hazards this planet poses. Today, we're going to focus on, as we have done on a number of shows, on visualizing information as a path to impact. This is not a new idea. The concept of the infographic seems new, but it goes back centuries. But we have so many tools and so much data now. We're seeing many new innovations around how to convey change, convey dynamics in ways that can hopefully alter policy or behavior. I've got several wonderful people working on the frontiers here, practitioner, researchers, and there'll be a student on shortly. And the two guests, the guests are all from Boston University and from an entity in Canada, MyHEAT.ca, which I've been fascinated with ever since I stumbled on it a couple of years ago. And we'll learn more about both of those in a second and meet the team here. And we'll start with that. Please share this live webcast with anyone you think might be interested now or afterwards. The same link you're watching on is a link you can share, again, now or later. I'm Andy Revkin at the Columbia Climate School, 39. Actually, this is my 40th year at professional journalism, which is sort of a scary concept when you write on the same issues for that length of time. But every day I see new possibilities, and that's why I'm here. Heather Clifford is chief data scientist with this project, visualizingenergy.org is the website at Boston University. You have also a position there. We'll learn more about the other work you do. Cutler Cleveland is the director and founder of this project, Visualizing Energy, and we'll learn about your academic roles as well. James Henry is with MyHEAT.ca, again, which is using sort of really interesting dynamic visualizations of both energy waste and clean energy sources to inform cities, a growing array of cities and communities, and possibilities and problems. And let's start with the BU folks, because you really, an email from a colleague of yours is what stimulated this conversation to begin with. And as the founder, Cutler, first just describe your background, because it's not like in visualizing data. It's more a wider, career looking at the issues of global sustainability. So tell us who you are and how you got to this particular project, and then we'll show some of what you're working on and get to Heather and then James.
Great. Thanks, Andy. Great to be here with my colleague and co-project leader, Heather Clifford, and James. I've looked at your work, and it's very cool. Can't wait to dive into that as well. So I'm a professor at Boston University. My tenure here is almost as long as yours in journalism, Andy, like 37 years or something like that. I'm a professor in the Department of Earth and Environment, which is in the College of Arts and Sciences. I'm also an associate director in the Institute for Global Sustainability, which is a pan-university institute which draws people together from the university's 15 or 16 schools and colleges and faculties. And I originally got interested in energy back in the very beginning of my academic career as an ecologist, as an undergraduate. an ecologist, as you probably know or may know, the energy and material flows are the currency of ecology. That's how they study how ecosystems are glued together. And I was lucky enough to work with some faculty and graduate students who are applying some of those same concepts to study human systems and the role that energy played in society, in the connection between society and the environment. And I kind of took that and ran with it and ended up getting a master's degree in marine science, and then a PhD in geography, where I was taking that by then a lot of social science classes, learning how energy and other resources are used in economic systems, and then really spent a lot of my early part of my career studying in sort of quantitative statistical terms, things like oil supply, the connection between energy and GDP, energy use in agriculture, and so on. And more recently, I've gotten interested in the connection between energy and climate change, obviously, but also between energy and human well-being, broadly defined, particularly issues of energy justice, climate justice, and related topics. And also increasingly interested in how to use simple stories, really scientific communication coming, from your field, Andy, although I'm not a credentialed scientific communicator like you are, but using simple stories and data visualizations to help people understand these important issues, climate change, sustainability, and really the defining issues for the students that I'm teaching right now at BU, and how we can help, mobilize people to understand these topics in a stronger way. And I'll just end this intro by just saying, Andy, I followed you when you were doing your .earth thing at New York Times for a long time, and you were really one of the first to really, I remember reading through your posts about, looking at the paleoclimate records and how you sort natural from an anthropogenic climate change before we kind of all sorted all that out. And those visualizations that you and others used were really kind of, I think, one of the early waves of applying data stories to getting the word out. So thanks to you for that work.
Well, I appreciate that. I still feel like it's a continual learning journey, James. I'm sure you, even as you're working on your project, which is in the commercial arena, you realize it's a learn and adjust kind of process. It's not like you're selling a widget. I think we'll get to that too in a second. So, and Heather, you could apply those data science skills to a host of issues, finance, so many things. What led you into this arena and to this particular project?
Yeah, so my background is my bachelor's is in environmental engineering, and I kind of wanted to switch into climate change. So I got my master's and then my PhD after, focusing on paleoclimate, specifically looking at ice cores, which are cylinders drilled from glaciers. Looking back through time, the oldest one I worked on was 2.7 million years, but more prominently, I worked on ones that were 2,000 years. And so we looked at a lot of pollution and going back those 2,000 years, and we kind of connected it to humans and how are humans changing the environment through time. And on top of that as well, I looked at different atmospheric dynamics through time and how that kind of relates to climate change in the past, how that relates to now. And one thing that I used a lot was coding. So I taught myself how to use Python early on in my master's because of the extensive amounts of data that is collected from these ice cores. And there was no other way to kind of go about it and to learn from these records than data visualizations. And it was very difficult at first, but because there's so much information that comes from them. So teaching myself how to kind of visualize the changes through time in different locations that I studied was very important. So that kind of led me into this space. So I didn't really have too much of modern day solutions because paleoclimate, you're really just looking at the past. And so the opportunity to work with Cutler on a project to bring to light modern climate energy issues using coding, using data visualizations has been very important and really beneficial. I think that our site so far, since our launch on January 17th, we've gotten some really great feedback, and people have been really interested in the visualizations, and I feel like they could really make an impact. And the resources that we have available publicly have been shared, and I hope that people continue to share them and look at them and interpret them in the way that they see fit.
So one of the themes seems to be utility, useful, being useful. You know, and I've had that same migration in my communication. A lot of journalism is essentially selling a product. You're selling your interpretation of the state of the world. And what I've been doing increasingly is facilitating other people's capacity to communicate around these issues. We'll explore some of the specifics on your site here in a second, but let's get to MyHEAT as well, which I think is a really interesting model. And so far, I think just restricted to Canada, but we'll get more from James. So James Henry, what's your thumbnail sketch of your journey that brought you to this particular project?
Sure. Thanks for inviting me on to discuss this, Andy. Yeah, so my background is marketing, business, advertising. So that's I did a master's in marketing and creativity. Who knew you could get a master's in creativity?
I didn't until right now.
I could use one of those.
Pardon, Cutler?
I said I could use one of those.
Yeah, it was great. Yeah, it was a European business school. So I was kind of making my way through the business space, advertising, communications. I ended up joining Google in Ireland, where I'm from originally, and spent 8 years there working in a variety of marketing and communications roles before getting involved with some of Google's really interesting sustainability projects. So I began leading partnerships after having moved to Canada. I began leading partnerships for Project Sunroof, which is Google's sort of large-scale solar potential data set and API. And also leading partnerships for Google's Environmental Insights Explorer, which is using their large-scale kind of Earth Engine data with some of their machine learning chops to help municipalities around the world with their GHG quantification. Through that role, I came to know MyHEAT as MyHEAT partnered with Google to develop solar maps, which I'm sure we can talk about. And I was really impressed, like you, Andy. It's one of those things that when you see the imagery, when you see what it is that MyHEAT does, it's like a light switch that flips on for you. And so I was very intrigued, and when I was ready for a change in leaving Google, I got back in touch with the folks at MyHEAT and have been here for 2 years. So now I'm the Director of Growth and Sustainability. My background is less on the data science side, and as Heather's, and as many of my colleagues who are very, very talented in this arena. But happy to represent here today and kind of share the impact of the imagery that we have and some of the things that we're working on.
Let's go back to Project Sunroof, which is kind of one of the underpinnings of MyHEAT. So that essentially is a way to track solar adoption, or
yeah, it can be used for a multitude of things. So in the US, Google has published this platform that you're demonstrating right now. So this is mostly available for every area in the US where Google has done some mapping. And so interestingly, the data comes from 3D high resolution mapping that Google does for Google Maps to build its maps models. And a few engineers in 2015-16 realized if you applied some solar irradiance data and averaged weather patterns, and again, a little bit of data science chops to 3D model, you could produce this really robust solar data set. So Google publishes this in the US. In Canada, we're a Canadian company. It's not available in the same way. So we partner with Google to access some of the data set and build a fully featured customer experience to really try and not track solar, but spark an interest in solar or visually communicate to someone in a matter of moments whether their rooftop might be good for solar or not. So that's kind of our secondary product, actually. And our primary product, as you're seeing on screen, is very, very visually similar. Is that rooftop view, but actually demonstrating the the heat loss for individual buildings at city scale using
Right.
aerial thermal infrared.
And this is actually what first I focused on first, because I mean, this is more relevant than ever in the United States now because of the Inflation Reduction Act
Yeah.
potentially flowing forward tens of billions of dollars to efficiency upgrades and the like around the U.S. And I'm sure in Canada, there's all kinds of incentive to do the work once you realize you have waste of energy. So how did that all begin too? This side.
Yeah, this so MyHEAT is really the commercialization of research that was conducted at the University of Calgary. So we are headquartered in Calgary. There's a professor there in geomatics, and the story goes that he was moving home, had been looking for homes that were rated as more highly energy efficient, or were looking out for indications that it might be a more efficient home. He wanted to reduce his bills as he moved. And so he moved in, he was all excited, and then his bills were the same, or if not higher than before. And, as the professor and scientist that he was said, I think I can try and figure this out. I've got experience in geomatics and remote sensing. Let me see if I can figure this out. And so he began testing what aerial thermal imagery could do to detect heat loss for individual homes at scale with a sufficient resolution and with enough insight to actually lead to taking action. So that was sort of 2015, 16, 17, and MyHEAT has been the commercialization of that since. And again, though we are a Canadian company, actually probably 90% of our work is in the US right now, where we partner with largely gas and electric utilities to support their energy efficiency programs and get this imagery into the hands of their customers so that we can, again, flip that light switch, create that spark of interest, and get them engaged in the variety of energy efficiency programs and rebates that are offered by either the local utilities or at the state or federal level.
Hey James, I got a question for you there. The really impressive tool there. I love seeing the granularity of the individual parcels. So have you had any, I don't know what it's like in Canada, but in Massachusetts and the US, you have a variety of incentive programs by different levels of government, city, state, federal, to incentivize rooftop solar. Have you had, has this had an impact on the policymakers who kind of want to promote uptake of rooftop solar? Are they using this resource, or are there options to expand that?
With respect to solar specifically, we do a little bit less work on solar in the US because the Google Project Sunroof platform exists. But certainly this kind of data has been used for policymaking and decisions. So on the Google side, the Environmental Insights Explorer that I led the partnerships for in Canada, that provides sort of an aggregate view of building and transportation emissions as well as solar potential. And so, what that means, because we have access to that data, at least for our Canadian partners, is we can work with a city and say, for your entire city, we think there are, based on this data, 125,000 individual rooftops that are suitable for solar. 30% of those are south facing, 10% are flat, 40% east facing, et cetera, the primary orientation of that. And we think if solar were to be installed, the average kilowatt size system, if solar were to be installed on all 127,000 of those homes, there's a 1.2 megawatt potential for your city over the next 10 years. So that kind of data is really, really powerful on the policy making and the analysis side. And then you pair that with a platform that has that visual impact for the individual residents. And I think it's a great 1-2 combo.
Have you ever run into the privacy question? I remember years ago, there was infrared. I've written a lot about infrared cameras and searching for leakage of methane is one thing, but also they were used to look for illicit marijuana cultivation in houses and stuff.
Right.
When you're showing a whole neighborhood like that, has that come up as a resistance problem, or is it not really?
It comes up as a question. The way that we think about it is the aerial thermal imagery, and specifically what we would refer to as the pseudo-colorized thermal image that we present of individual rooftops, that red to blue sort of gradient, that while very powerful from an insight perspective for energy loss, from a privacy perspective, it's very, very benign. It's most certainly not an X-ray. Does not tell you if people are inside the home or how many people. We restrict the image to the outline of the building as well. And so if you were to compare, our image to a Google satellite image, you can discern a lot more information from that satellite image, right? You might see how many cars are parked in the home, what's in their backyard, what's nearby. You can discern a lot more about that home and the individuals from a Google satellite image than you can from our image. And the heat loss itself, the heat loss map that we apply to each and every building, on that concept of identifying individual homes that, for whatever reason, might be using more energy than others. We compare and calibrate what we describe as our heat rating. So we have a 1 to 10 heat rating, which is a relative measure of heat loss. And we do this by classifying buildings within the area we've mapped into residential, commercial, industrial, and then within residential, single family, multifamily, detached, semi-detached, et cetera, so that we can kind of cluster them into those segments and then calibrate heat ratings and heat loss across them as a relative measure. So you don't end up seeing any one home that's kind of glaringly bright red. That heat loss map for each home is distributed evenly across the roof, and the heat ratings are calibrated against other homes. And so that's another step towards privacy, where it kind of helps to improve the anonymity by demonstrating heat loss in a powerful way, but by doing so relative to other homes.
It's interesting. I can see some industries really interested in this data, because potentially, I wonder if people are doing this. In Massachusetts, they ran an experiment, which didn't last that long, where you would get a piece of mail, snail mail, which says your household uses blank more kilowatt hours and spends blank more or less energy compared to your neighbors on your street.
Yeah.
And so they would use that to try and incentivize you to, take up one of their energy efficiency programs. And clearly you could use this data if you also wanted to try to sell some service for heating or cooling, since you have parcel level data.
Yes, you can. So that roughly what you're describing there, and it has various flavors, but is a home energy report, something that looks at your recent historical energy consumption and compares you to yourself previous months, or compares you to other homes nearby, other similar homes. So it's a common behavioral science technique to nudge folks into taking action. And so there are definitely elements of what we do, especially that 1 to 10 heat rating, where we compare that to similar homes nearby, where we also use that same home energy report style behavioral nudging. The combination of the imagery makes it a lot more powerful. There's a study from the UK, which measured the impact of thermal imaging on customers.
I'm actually showing it.
Perfect.
I'm showing it right here. Nabin Powell.
I think the key stat here was that customers are 5 times more responsive, 5 times more likely to take action when they see thermal images of their home. And so, yes, so that's one of the primary use cases is taking elements of behavioral nudging from that home energy report style approach, combining it with the power of a unique image that's for someone's home that they may never have seen before. And then at that same time, capturing that interest and prompting them to take action. And that could be, hey, get a home energy audit. It could be a full weatherization. It could be some DIY air sealing and caulking. It could be new windows and doors. It could be get a heat pump. There's a variety of different endpoints that we can use that initial interest we've captured to funnel people towards.
So we have a new guest who's arrived after getting out of class, Lucia Villalonga. Am I pronouncing that correctly? Hold on. I think you're muted, but it doesn't look like you're muted. Let's hear from you again. Sorry. I'm not sure why I can't hear you. Can others hear you?
No.
Try now. I think I hear you now. Oh no.
Interesting.
Maybe you log out and come back in, and just check the microphone setting. There's an option for what the microphone can be. So see if you can come back in. Great. We'll get back to Lucia in a second. This issue of what motivates me here is, how can information change, inspire change? I did a post and several other webcasts on this. This was a post, can innovative imagery overcome big number numbness? This is on the loss side, the harms that we're facing, stalling action on everything from COVID to climate change. And there were some really interesting examples there too. So let's get to that question. One thing that I've learned from Sabine Paul and others, she's the professor who did that work in England with others, is how little research funding there is in this arena.
Mm.
It's just like when you compare, if you think about carbon mitigation funding, there's billions going into carbon capture, even more now. There's billions going into clean tech, improving batteries. But there's a few millions going into analyzing, does imagery change us? How can it change us? Even the warming stripes, everyone who knows about climate has seen those wonderful historical blue to red stripes from Ed Hawkins. I had him on his show a year or two ago with a young scholar in England her PhD is in art and climate. And she said, basically, there's no data yet to show whether that warming stripes thing is changing anything. It's on the cover of The Economist. It's on dresses and ties. So I guess this gets to the next question. And then we're going to dive into the Visualizing Energy website. But James, you're a practitioner. You're on the front lines here. So whether it's through the work of MyHEAT or others, is there already evidence that this can change behavior? We talked about electric bills. It definitely, here in Maine now, we have much more information because of this smart meter, right, where the energy is going, so it's changing my behavior. But I don't know, generally, is this still too early to know, or is it demonstrable?
I think it is. It's definitely not as sexy as other aspects of climate science and climate tech that are, on the receiving end of a lot more funding. But I definitely think it is changing things. It comes down to, in part, to your point, data that's relevant and personal. And by that, I don't mean more personal, infringing on the privacy side. I just mean personalized, something that's relevant to the person that you're trying to talk to. So imagine, Cutler, I think you mentioned the receiving the hey, you used X% more energy this month. That's a step towards personalization. That's great. If that piece of mail that you might have received just said, hey, some people use more energy than others, you should probably think about how you might be able to improve your energy. That message is a lot less effective than you've used 12% more than last month and 20% more than your neighbors nearby. It's time to take action. So it's the kind of the relevancy and the personalization, and that's something that we try and impart with our partners by combining our data set with theirs to make for a more powerful, personalized approach. And we've had a couple of randomized control trials, so where we've got a couple of a control group, a treatment group who see our imagery, and those who don't. We do have a couple of academic research papers on those that have been published. So Andy, I'd be happy to share those with you, or Heather or Cutler here as well. That demonstrates when folks are shown that imagery, that personalized nature, the data, it is changing behaviors more than less relevant, less personalized, and more generic approaches. So yeah, I see it happening for sure. And it's maybe just not getting the same headlines as carbon capture or other technologies are.
If I could just, one thing to add to that, that's really interesting, James. Andy, to your point, now speaking about the US, in terms of research in academia, energy is, a cross-cutting theme across, almost every discipline, certainly in the natural sciences and social sciences and engineering and business. And so almost by definition, in places like NSF and other places, there's going to be less funding for it, because while there have been improvements in interdisciplinary funding, it's still very siloed. And within the federal agencies, like national labs, it's very much a focus on basic science and engineering. And so some of these
Right.
really interesting applied social science questions just have not been prioritized.
This is certainly something I've seen. So Heather, we were talking about data.
Yep.
And how do you choose your stories? Essentially, the website is filling with ever more stories or projects or questions. And then what's the process? Do you start with the data? Do you start with the question? And how does that hash forward?
We start mostly with a topic. So some of the topics we've kind of touched on so far is health, sources like renewable energies, well-being, energy justice. And so we started off with well-being as kind of like our baseline for something that's important to energy and the energy transition. And we kind of moved into also talking about Boston, which here this article talks about energy use in Boston. So we kind of start with a question and we want to answer this question. Sometimes we start with the data and we mine the data and we find the story within that. And then there's other times where we're asking a question, we need to go find the data that could answer this question. And then once we have the data, we kind of figure out, all right, what's the best way to translate this data so that a layperson can understand what is happening? So say with this diagram, we have a Sankey plot that kind of shows the transitions from natural gas energy losses, all the different energy uses, to energy services and energy losses. So we kind of have to use the resource we are currently using, which is Flourish, and decide what type of graph is going to best translate the data to make it more accessible and more digestible for lay people.
Hold on, I see Lucia coming back in. Let's see if we can get some audio. Lucia, can you hear me?
I can hear you. Can you hear me?
Oh, great. Perfect. Yes.
Yay!
Wonderful.
Fantastic. So before we move forward too far, can you just fill us in a little bit, fill the audience in on what drives you as a student toward this arena? I see you're looking at AI applications also in your outside of the work you're doing on this. But I understood that the visualizing energy students were involved in actually helping launch this project. So a little bit of your backstory. What brought you to this question and this approach?
Right. Yeah. I don't know if Cutler mentioned, but visualizing energy actually started as a textbook. And then it became a website, and now it's sort of a full data science platform. I have I guess some background on myself. I'm a statistics master's student right now, but I did my undergrad also at BU in computer science and statistics. So that's kind of always been my wheelhouse. And I have other interests in sort of like climate science and especially energy, sustainable energy. So visualizing energy just kind of seemed like the best or a very good meshing of those two interests in a way that I could be directly involved. And I love how the visualizations are turning out.
Do you find one of the things about this arena, for sure, is it requires multiple disciplines talking to each other. It requires even the humanities talking to the sciences. On most campuses, that's really hard. At Columbia, I started building my sustainability communications initiative 2019. And the whole idea was to cross all those old barriers, break down walls, get people together. COVID made it harder and easier in some ways, but it's always tough. And I don't know whether as a student, either undergrad or now, you feel that the system at universities is improving to create that kind of crossover, or is it still hard?
Yeah, that's a good question. I think departments are still very siloed in their own sort of, professors teach their own classes and students take those classes. But I guess in a general education perspective, the College of Arts and Sciences at BU is really large and it encompasses a lot of different departments. So I think from a student's perspective, taking classes, there's a lot of cross communication there. I can't quite speak to the research yet.
Okay. So you're in your master's degree. Where you're heading there? Are you already deep into a thesis, or are you in the early stages?
Early stages. Yeah.
Any rough idea?
Well, I had a meeting earlier today with a research group about using machine learning to solve partial differential equations in ocean surface temperature modeling, with some other applications to you could make it more complex with not just temperature, but wind. And especially, I think the goal of this project is to predict rainfall in droughted areas.
That's really exciting. There's a big group that I'm helping out at Columbia with an NSF grant, it's already almost 2 years old, a project looking at AI applications for climate modeling, sort of, I guess, getting at those the equations that are used to estimate the way energy and other things flow from box to box. So that work is really important, and good luck with it.
Thank you.
Heather and Cutler, can you take us through how you sort of build your story list? I'm calling them stories. They're this line between what's journalism and what is communication, and other kinds of communication is getting fuzzy anyway. I don't pay so much attention to it as long as there's verifiability and utility. So how do you kind of choose your targets? I know we talked about this a little bit, but you did some local things. You've done a lot for Boston, and then you're doing these sort of global scale questions as well.
I'll take the first crack at it and turn it over to Heather. As Heather mentioned, most of what we're doing is driven by topic areas and questions we want to answer. And of course, energy is a humongous field. And so we've taken a slightly different approach to the topic than how energy is treated in other kind of web-based resources on energy, which typically, and there's a lot of very good ones that have good data and visualizations, they're typically organized around sources and technologies. So oil, gas, coal, nuclear, renewables, and then end uses such as transportation, power generation. And we're taking a different approach by looking at really starting with human well-being and looking at different aspects of well-being, all the way from access to safe water, to sustainable livelihoods, to equity, to income generation, to employment, taxes, subsidies, policies. And those social and human issues cut across every energy silo. And so we're looking at some of our initial areas that we're focusing are on how we think about human well-being and what is the connection between access to safe drinking water, health, income, and so on, and energy use. And also issues related to energy and climate justice, the very stark disparity in not only the exposure to the hazards of the energy system across different socially vulnerable populations, but also increasingly access to clean energy and all the new emerging technologies like electric vehicles and heat pumps, that unless we design this energy transition with equity in mind, those same folks are going to be left behind. So that's the way. So we're building out the content from those questions, and in doing so, we'll cover a lot of the important information related to traditional topics of sources and technologies, but with a human focus.
Yeah, that's so important. I've tried to make these points over and over again about the trade-offs that are sometimes glossed over in the push for decarbonization. Did several shows on what I'm embracing calling mitigation. You may have heard of maladaptation, where big adaptation projects turn out to be problematic in ways that can be unjust and dangerous for other folks. And the mitigation is the same, and cutting off financing for, let's say, natural gas development in Ghana or Mozambique by rich countries is highly resisted in countries that hardly have any carbon footprint. And making that point, whether it's visually or otherwise, is really important. But then you get to the question of, is anybody interested in that? I find it really hard to have kind of the climate-focused community acknowledge some of these trade-offs. I don't know whether you've seen that so far. You're still kind of the early stages, but maybe that's already happened or not. And this could be for Heather or Lucia or you.
I think it's hard to get people, most people don't find focusing on equity uncomfortable. And even though there's a lot of very sound research which shows that many aspects of overall well-being for society as a whole are undermined when there's inequity in income, wealth, environmental exposure. So improving equity outcomes helps society as a whole, but there's a lot of personal and powerful entrenched interests for not doing any type of reallocation of access to resources, environmental, financial, and otherwise.
Yeah. How does that come up for anyone else too? Is this, I did a show on this question of energy justice, getting energy justice more enshrined within what's called climate justice. Destiny Knock at Carnegie Mellon has been doing really interesting work both in Africa and in the United States on the cost, the household health and well-being cost of energy poverty. And she's very climate focused at the same time. And I think it's just really important to try to make that case. And actually, James, I was going to ask you, your data, I know for sure that weatherization, sort of the insulation properties of homes is much less in communities that are poor, in communities that are marginal or of color. And I don't know whether that data set is being used also in that way, looking at mapping for cities where it's not just the homeowner's decision, but it might be the landlord or the public housing, that kind of thing. Is there potential to use that data in that social arena too?
There is, absolutely. More and more every day, folks out there that we're speaking with are expressing a desire within their teams, within their senior management, from the CEO down, to start focusing more on energy equity and reducing energy poverty. And one of the ways that our data set can be used to do that is by combining the data that we produce from our mapping with census data that's available, and from any data such as energy consumption and other kind of flags or attributes that, say, a utility company might have. So they may have, what is the heating source? What is this a renter occupied or owner occupied? Combine that with census and our own data, and all of a sudden we can sort of paint a picture that might look like, here are 1,700 homes in this neighborhood where the average income is lower than $50,000, where 30% is renter occupied, and where there's a high heating loss, i.e., the MyHEAT rating of 7 to 10. All of a sudden, that helps you sort of focus your energy, your resources, your dollars, to getting closer to the challenge. And in doing so, what we also think about is trying to minimize that free ridership effect. At any given state level or utility energy efficiency programs, there's X number of dollars to spend. And if you have a large majority of those dollars being spent on, or if you have a large percentage of more wealthy individuals and households applying for those rebate dollars, there's less in the pocket to allocate towards those who need it most. So by applying that sort of data segmentation, you can get a little bit closer to the challenges at hand. One of the other issues, though, that we see is that weatherization is great, and yes, there's a high chance that neighborhoods, disadvantaged, kind of overburdened communities have higher needs for insulation in their home. But it's also a bigger ask to get someone engaged to the point where they may have never thought about energy efficiency before. It's a big ask to get them to start thinking about it, and then all of a sudden go straight for full weatherization and insulation in their home. That's maybe a big jump, especially where rebates and or financing and other options are just not well designed with energy equity in mind. And so one of the things that we're thinking about in conversations that we're having is, how do you design an energy efficiency journey that takes someone from maybe a starting point that's less involved, that requires less of a commitment. Maybe it's hey, let's work with some community organizations, some boots on the ground, to do some DIY air sealing and caulking in the home, right? It's a nice, low friction, easy step to start to build a relationship with folks in those communities, still bring them on an energy efficiency journey, but not expect them to go from 0 to 100 with full home weatherization, just because you happen to have a program that still requires them to pay $2,000 up front, or still requires them to get financing, even if it's a low percentage rate. A lot of those programs aren't super well designed today, unfortunately. But the application of the data set and the segmentation that I described is one way to get a little bit closer to those folks in those communities and deliver the dollars more effectively and minimize that free ridership.
So I haven't asked you all yet whether, you've just been learning about each other here so far, but is there cross-fertilization possible? Are there academic partners that should be talking with MyHEAT? What do you think as you're seeing this stuff up in Canada, Lucia and the others?
Sorry, is that directed to me first of all, or?
Well, more to the BU crew.
Sure.
I got some ideas, but I'm going to ask Heather and Lucia to go first.
Yeah.
Yeah, I mean, this definitely cross-cuts with what we're trying to do. We have some articles on weatherization and looking at census data. And right now we're doing some research on mass save and LI heap, trying to, bring it to the forefront, bring these issues to people. We're trying to use social media platforms as well to try to get the word out and get the visualizations out and get these articles out so that people can access them. And I think that this kind of cross-cuts with exactly what we're trying to look at with these different incentives.
Actually, I do have a question, another one for James. You said that in the States, there's already Google's Project Sunroof and stuff. Is there a similar heat mapping entity in the States, or is that just the solar part?
Not really, not to my knowledge. Not at least in the scale that we do it. So of course, sorry, Cutler.
I said, darn, there goes my big idea that I had for collaboration.
The good news is we're available for more work in the US.
So I guess, are the data there? In other words, would there be a way to have that happen in the States? Because it
so my take on your previous question about cross collaboration here is yes, I think that would be really, really interesting. I'm a big fan of data visualization. Some of the work that you folks have done on the Visualizing Energy site is really, really great. I don't have the coding skills to do that, so collaboration would be excellent. And we do have data. We've mapped over 5 million homes, representing roughly 20 million in population, with a large percentage of that in the US. So we do have some really interesting data sets, predominantly right now in the kind of US Northeast, and obviously
Massachusetts?
Not yet. But
here's where I'm going to. Here's an interesting cross-fertilization. So I have another member of our team, one of my PhD students, for one of her papers in her dissertation, is going to look at the data from Mass Save. So Mass Save is the big utility-run program where there's a tax on your energy bill, and they send it back to customers for energy efficiency, weatherization, and so on. Yeah. We have very, very detailed data to the sub-block group census on who is getting how much money for what types of weatherization. And so it would be really interesting to tie that information into the information that you generate to see, well, are the houses that need it the most getting the aid? Where's the gap between what these programs are who they're actually serving, and where the potential is? So that's maybe something we can talk about offline.
I'd love to. It goes back to the point I made about designing an energy efficiency journey. If you know that a household has already participated in, element A of that mass save program, for example, we can take that data back in and say, oh, okay, great. They've already started with step A. Let's change the message we put in front of them and say, now you've got step B and C as your next steps. Really kind of making that journey clear again for folks who energy efficiency is not a terribly sexy topic. We try to make it sexy with the imagery, but it's not top of mind for folks day to day. So making it as easy to understand and making it a clear journey is important. So yeah, I think that's a really excellent idea. I'd love to talk about that afterwards for sure.
Well, we have about 10 more minutes. And again, I really appreciate all your time on a Friday in one of the, this time of nonstop work needs and stuff. But I'd like to keep the focus on this kind of discussion going forward. What are next steps? what are stories that haven't been told yet. And I do think, at least in the States, I keep coming back to the Inflation Reduction Act and the bipartisan infrastructure bill, which really flipped for the first time in all my experience as a journalist through more than 30 years on this beat, the issue now being one of opportunity as much as restriction. It used, the storyline was all about restriction, regulation, which still has to happen, but not so much about opportunity, expanding resilience and energy transformation. So this and getting the communication component in there, I think, is really vital. I'm going to play. This is not even. It's about a minute. I'm going to play something that Jigar Shah, who runs the Energy Department's loan program, said last year before the IRA was passed. So this is just based on the money that was already allocated for a chunk of it for resilience and energy change going forward. So hold on 1 second while I do this. Stop screen, share, share screen. There's no producer behind the curtain here. Just me.
You've got this, Andy.
Here we go. So here's Jigar Shah. It's quick. It's fun. Let me just. I don't know why it's being weird there. Should be able to hear it.
Thousands, actually tens of thousands. We have thousands, actually tens of thousands of people who are already active on these issues. When you think about what this takes, we have 19,500 organized cities and towns and communities in this country. That's it, 19,500. 14,500 of them have a population that's less than 5,000, right? And so what this requires is sustained effort at the local level, always, right? When the transit authority makes the decision to replace old diesel buses with something else, they need to choose electric buses. And we have programs to pay for it. But if the transit agency doesn't apply for the program, it doesn't happen. And I can't force them to do it from the federal government. All I can do is say, here are all of the resources. But someone in local community can force them to make a decision that's in their own best financial interest. The same thing's true with the way in which school buses are done. You know, only 50% of streetlights in this country are LED. We could replace all the rest of the streetlights with LED lights. It's like an 8-month payback, right? The amount of school rooftops that don't have solar on them when it's fully financeable and you save money from day one, right? I mean, what it takes is someone who actually is willing to spend a few extra hours every week to say, you know what, I want to make my community better. And the federal government's passed $1.2 trillion to support that, but we can't force it top down. That's not how our country works, right? It's got to be forced at the local level with resources that we provide to that, change maker and that muckraker.
So what's relevant here, I think, is you're talking about the resource being information conveyed in a mapped way, so communities can uptake the understanding. Let's think about whether rooftops on schools have a solar panel or not. Those are public facilities. You can have a conversation built around, should it be a white, should it be a green roof? Should we plant stuff there, or should it be solar? I was going to ask you guys about the streetlights. I was thinking, has anyone used nighttime? Is there a way to discriminate between incandescent and LED streetlights? So you can go to a city council meeting and say, look over here, they all have the LEDs and they cut their energy budget like by 2/3, and we still have the old style streetlights. I just wonder, this idea of mapping information, particularly for community, but with community utility in mind, seems like a pretty cool mix with what you're all trying to do.
I can briefly touch on that one. That was an interesting comment about the lighting. In the line of work that we do, our utility partners are constantly looking for ways to drive greater energy savings. But actually more and more, the lighting rebates that once existed are going away. They've sort of already captured a lot of that low-hanging fruit, a lot of those short payback windows. They've converted a lot of their customers to LED lighting, customers across residential and the commercial and industrial. So at least what we're seeing is that lighting is less and less of a focus because they've already kind of reached a certain critical mass of adoption, and it's those incremental gains are harder to achieve. So this is an interesting comment. I think you mentioned it's from a couple of years ago. It'd be interesting to see the percentage difference now, but the gains in energy efficiency and reduction are very well documented from LED switching. So again, I don't think it's a case of sort of proving it. It's more the communication around it. So back to the whole central topic that we're talking about right now.
Right, back to the communication component. And from BU, at the end of this year, or what's your goal, or what would make you feel like the project is working the way you anticipated? Or is there anything I can do or others can do to help build things forward?
Heather, go for it.
Yeah, I mean, I think that with the project, we hope to get more collaborators. We hope to get more people that have, say academic articles that they want to be more accessible with our data visualizations, and get more connections with, say, like cities, local communities, and ways that we can communicate, like this type of information in a way that's more accessible. And then also hopefully, following on social media, because that's, I feel like, a really great way to get information out to regular people that want to learn more about this topic. So that's kind of where we're kind of looking at more types of softwares besides just Flourish, say like ArcGIS, look at more intense mapping, visualizations, but making everything more accessible.
Great. Well, why don't we leave it there? And maybe we can revisit when some of these collaborative ideas start to gel. I'd certainly like to keep working with you all at BU. I'm all about crossing all the typical boundaries. That this is not a one school problem. This is a global opportunity, and we have to think of it that way. So thank you all for being here today. Heather Clifford, Cutler Cleveland, Lucia Villalonga from BU, Boston University, Visualizing Energy, and James Henry from where are you? Are you based in Toronto? Where are you in Canada?
I am based in Toronto, yes.
Well, thank you for being part of this show today. Again, I'm showing there's the it's at Visualize Energy is the Twitter account. Twitter does still matter. I could probably show you an Instagram or other accounts for the BU project. And MyHEAT.ca is where you can learn more about the heat and solar mapping of that entity. Thanks again. This is a Columbia Climate School Sustain webcast, trying to drive progress on a complicated planet, one conversation at a time. Andy Revkin signing off. And thanks again. Have a good weekend. Be safe, and let's keep in touch and drive everything forward together.
Thanks, Andy.
Thanks,
Thanks,
Andy.
everyone.